HelpMeWithStats.com was used to create this tutorial that can help us create sample mean distributions. In this display, we have a flight of 16 passengers on a small airplane. Each passenger is represented by a square, with the area of the square indicating the passenger weight. Very small squares are babies, and very large squares are large adults. Each flight is a sample of the population of flying passengers. The average weight of the passengers on a flight is a sample mean. Here we have a sample of passenger weights that produces a sample mean of 160.88 pounds. Notice that this sample mean is 5.88 pounds higher than the population mean of 155 pounds because of sampling error. This sample mean creates a column in the 160 plus interval because each interval is 5 pounds. With only one sample mean, we have only one column in the histogram. We've added a second sample mean of 132 pounds and updated the display with another blue column that represents the mean passenger weight of 132 pounds. A sample mean of 132 pounds will be in the 130 plus interval. We've added a third sample mean of 174.63 pounds and updated the display with another blue column that represents the mean passenger weight of 174.63 pounds. A sample mean of 174.63 pounds will be in the 170 plus interval. We've added a fourth sample mean of 154.69 pounds and updated the display with another blue column that represents the mean passenger weight of 154.69 pounds. A sample mean of 154.69 pounds will be in the 150 plus interval. We've added a fifth sample mean of 151.25 pounds and updated the display with another blue column that represents the mean passenger weight of 151.25 pounds in the 150 plus interval. This is the second sample mean in this interval, so we increase the height of the 150 plus column. We've added 5 more sample means and produced a histogram. The distribution doesn't have much of a shape yet. With 100 sample means, the distribution is starting to take shape. There are more sample means in the middle of the distribution than on the ends of the distribution. With 1,000 sample means, the distribution is looking much more like a normal distribution. With 10,000 sample means, the distribution is looking a lot like a normal distribution, but the distribution is not perfectly normal due to sampling error. In order to have a distribution very close to normal, we would need a very large number of sample means, for example, millions. For more help with statistics, HelpMeWithStats.com is a free website that has more than 70 tutorials, as videos, or as self-paced slideshows. You can also learn how to conduct more than 60 statistical analyses by watching videos that show complete solutions, or by working through an unlimited number of examples using the step-by-step problem solvers. Finally, you can access a comprehensive stats textbook with more than 685 review questions. Thanks for watching. If you find these resources valuable, please share with your friends, teachers, and professors.